The good thing is that, well, I don't know, it's kind of at the beginning though. So if we talk about something inappropriate, like in the middle, no one's ever going to get to that far. Like no one that's not in this class is really going to watch that much math video. A question just like this on homework I'm going to give you tonight. It says draw the graph in the same viewing window, which means if you have your graphing calculator, you can do that. I'm going to kind of draw it by hand so you can see that as well. And on your homework, you definitely can use your calculator just so you can kind of see the idea of a tangent line and a normal line, which we're going to do in just a second. So I think these are the notes that, did I not hand these? I handed these out on Friday.
Started here.
I thought I handed them out on Thursday, but I made you write them on Thursday.
Yeah. So I accidentally wrote the same ones for Friday. All the pages the Thursday. Thank you.
Oh look, right here, laying on the ground. Here you go. Okay, so find the slope of the curve and the equation of the tangent line. All right, we haven't found the equation of the tangent line yet. All we've done is find the slope, so that's a new part. But step one, what do you do when it says find the slope of a curve at x equals -1? The h thing, the limit thing. So to find the slope, you're going to do the limit as h approaches 0 of f of x plus h. If they give you an x value, I'm going to plug it in. So I'm going to say f of -1 plus h minus f of x, which is -1. And again, every time you're subtracting x plus h minus x, so every time the x's cancel out, so that's why we can just say there's an h in the bottom. Wednesday, when we have a test, you have to know that definition. Like, you have to be able to do that. Yes. Because they told me to find the slope at -1. Oh, well, the h comes from the definition, right? Like the x plus h minus f of x, because that h value is the getting closer and closer point. Okay? Sometimes people like to keep it as x, and then at the end they plug in -1, and that's okay, but I feel like I like this way, so I'm going to do this. So then comes the step of having to be able to do the algebra, having to be able to simplify correctly. Technically, we really should be rewriting this limit every time, because until you take the limit, you should be writing that you have the limit out there. If I'm going to do -1 plus h, that means everywhere there's an x, I'm going to replace it with -1 plus h. So I'm going to get -1 plus h squared plus 2. Right? So in that function, I just replaced x with -1 plus h. Minus, I'm just going to plug -1 in there, and you're welcome to work it out. You're welcome to just replace x with -1 and then work it out later. But if I plug -1 in there, am I just going to get 1 plus 2, which is 3? So I'm just going to say that's -3. Or if you wrote 1 plus 2, it's going to work out the same way. Sometimes with lots of x's, I'll just write it out. I can work it out later. But that one wasn't that bad to do. With me so far? Don't make a silly mistake here, right? You're foiling this out. So if I FOIL that out, I'm going to get 1 minus h would be minus 2h plus h squared. And then we could go ahead and say if you want 2 minus 3 is -1, since it's just 2 minus 3 there. And again, what should happen every time is that we should be able to simplify this so that we could factor an h out. And again, we're going pretty basic right now because we're having to do it the long way. But I do want to be able to see this. So if I factor my h out and got -2 plus h all over h, the idea is this gives me that slope at exactly x equals -1. So now when I plug in 0 for h, I just get negative 2 plus 0, which means my slope of the tangent line is negative 2. So it's really important to understand what the question's asking. If they just ask you for the slope of the curve, that's it. You're done with the problem. But this one says find the slope of the curve and find an equation of a tangent line. So a tangent line we talked about is this linear line. So if we want to write a linear line, what's the form of equation that we can use? Y equals mx plus b. We just found m, right? When you find the slope of the tangent line, we just found it. So all we need is a b value there. How am I going to find b, do you know? I need a point, right? I need to plug in an x and a y. At what point am I writing this tangent line for? At negative 1, right? So they don't give me the y value, but if I know that x is negative 1, can I plug in and find the y value that goes with negative 1? Yeah, so when you're writing an equation of a tangent line, or when you're writing any linear equation, you just need a point and a slope, right? The slope you just found, the point, you have half of it already, all right? And so I can almost guarantee on the AP exam, which is a long way away, but on one of the free response questions, they want you to write an equation of a tangent line, and you just got to find the slope, and then you got to find the point that goes with it and plug it in correctly. So if I want to plug in negative 1 into the original problem, we already did that somewhere, right? Wasn't it just 3? And we know that our slope is negative 2. Now I just need an equation. So we have two options here, all right? One option is we tend to go straight to y equals mx plus b, because that's what we did so much in Algebra 1. We can plug it in. We could say 3 equals negative 2 times negative 1 plus b. So 3 equals 2 plus b, b equals 1. Agree with that? So I would get y equals negative 2x plus. That is an equation of a tangent line, which is honestly what we're going to focus on for the rest of this semester. Everything we do centers around these tangent lines and these equations for tangent lines, which is why we spend so much time on it at the beginning here. But just FYI, if you're trying to write an equation of a tangent line, especially if you're not going to graph it, I'm going to keep stressing to you that I think point slope form is a better option. Right? Remember point slope form? Why do I like point slope form? Because you just got to plug it in and you don't have to do anything, right? Like you could just say y minus 3 equals negative 2 times x minus negative 1. And this will get you the same credit on the AP test as that will. And you might say, well, I could get to that really easily. I just have to work it out. You don't know how many people make silly addition mistakes or negative sign mistakes. If you had this and you simplify it wrong and your final answer is wrong, they don't give you the point for it. And so I just like to encourage you that point slope form is great because you don't have to do the algebra. Feels wrong, but it's okay. All right? They do, but and the reason is because graphing, right? And on this one, they want us to graph both of them, so honestly, that one makes a better sense. But on the free response stuff, to get your point, you could do it like this and have less work to do, I think. So until I taught calculus, I never stressed point slope form. But after I taught calculus in algebra even, I'm like, point slope form is the way to go. All right, so let's graph these really quick. And if you have your calculator, you can do that. We're going to graph this, and we're going to graph our tangent line. So we're going to graph y equals x squared plus 2 and then our tangent line was negative 2x plus 1. Is that true? Oops, go the wrong way. Negative 2x plus 1. So I'm going to do this by hand, which means it's probably not going to be as accurate as yours if you had your calculator. But I still don't have my calculator on here yet. So. X squared plus 2, what kind of shape is that? A parabola? You can always just make an XY chart, or hopefully remember plus 2 means it moved up 2. Right? So if I plug in 1, I would get 1. Right? If I plug in 2, do I get 6? You get something like this. So what we found is we found a tangent line at x equals negative 1. Which means, hopefully, at negative 1, this tangent line is going to touch there. So that would be a y-intercept of 1 and a slope of negative 2. Should be like right there, right? Is that true? No? Yes? Up 2, back 1, up 2, back 1. That kind of looks like on the graph. And so that would be the tangent line for x equals negative 1. If we found the tangent line for x equals 1 or x equals 3, that's a totally different line because it's at a different point on the graph. But that is where it is tangent, and you can keep zooming in there and see that it really does just touch there and it gets really close on either side of it. And there's a whole lot of stuff we can do with tangent lines that we're going to spend the rest of the semester doing. Okay? Okay, here's your last new thing you got to know for this chapter. Normal line. A normal line is the line perpendicular to the tangent line, which means if you found the tangent slope, or if you found the equation for the tangent line, it's really easy to find the equation for a normal line. And I even told you there that maybe you don't remember, but perpendicular lines have opposite reciprocal or negative reciprocal slopes. So I said, let's write the equation of the normal line to the function in example 5. So remember our function in example 5 was f of x equals x squared plus 2, and our tangent line was y equals negative 2x plus 1. So now you just have to know normal line means a perpendicular. So if the slope of the tangent line was negative 2, what is my slope of my normal line going to be? Perpendicular. What kind of slope does my normal line have? Positive 1/2. It's opposite sign and it's reciprocal. So positive 1/2 is going to be my slope. And it's at the same point, right? So the normal line is the line perpendicular to the tangent at that same point. So I'm still using the point negative 1, 3. So we could say y minus 3 equals 1/2 times x plus 1. Again, that will give you credit. My advice to you is check the back of the book and how they write it. You should check and make sure yours matches, because multiple choice, you have to match it up. For your response, you could leave it like this. I'm going to graph this also, so I'm going to actually change it over. So what would that be? 1/2 x plus 1/2, so plus 3 y equals 1/2 x plus 7/2, or plus 3 1/2. I'm going to go back really quick just to show you. And if you have your calculator, it's kind of nice that you can graph it and see what it looks like. So normal is 1/2 x plus 7/2. So 3 1/2, and then up 1 over 2, down 1 back 2. So that green line should be perpendicular, form a right angle with that red line at the point that it was tangent, and it does. It does cross over to the other side, but that's okay. It's not a big deal. We're just checking at this point is what we're looking at. It really doesn't matter what's happening outside of that point. All right, so just kind of some practice, kind of some reminders about perpendicular lines. Normal lines are not a huge part of what we do in calculus. Tangent lines really, really important. Normal line, not that important, but it definitely will be on your test this week, just to have you find a tangent line and a normal line. Questions about that? Okay, I think I got one more example on there, don't I? Here. Piecewise. What's wrong? Okay. We're going to talk a lot more in chapter 3 about when does something have a slope of a tangent line and when doesn't it. There are certain cases that it doesn't. But for now, we just want to talk about checking the slope on both sides. So it says determine whether the curve has a tangent at the indicated point. If yes, give the slope. If not, explain why. This means we just have to do this twice. So we want to check, again, with piecewise functions, we're really always checking for that point where they meet up. So that's why we're going to check at 0. So basically, I'm going to look at the slope on the left and the right side. So if I look on the left side of this graph, I'm going to be using the function f of x equals negative x. And I'm going to do that limit definition. The limit as h approaches 0 of f of x plus h, 0 plus h, minus f of 0 all over h. It's really nice when it's a 0, right? That's just f of h, right? Because 0 plus h is just h. So that's just going to be negative h minus 0 all over h. Negative h minus 0 is just negative h over h. Is really just negative 1. You with me on that? If you ever do a limit and you just get a number, that's okay. That just means that's the slope always. And if you think about it, maybe we don't even know how to do this. Is that a linear equation? Negative x. What's the slope of negative x? Not your question. It's negative 1, right? So a linear line has the same slope all the time, which is why when you do this fancy definition, you just get a slope of negative 1, because it's always negative 1. With other functions, the slope changes depending on the point. It's not a constant slope, which is why you do that. So let's do the right side here. And if you notice that on your homework, if it's linear, you don't have to do the whole thing. So if I do just f of x equals x squared minus x at x equals 0, that was a little more complicated. So you get f of, again, 0 plus h minus f of 0 all over h. But now we're using that bottom function. And I'm going to write it down here because otherwise I don't think I'm going to room. Again, 0 plus h is just h. So that's just going to be h squared minus h minus 0 all over h. So again, the minus 0 really isn't important for the problem. So I can factor the h out. And I get the limit as h approaches 0 of h minus 1 is going to equal what? Yeah, 0 minus 1 is just negative 1. So because these have the same slope on both sides, we can say that it does have a tangent at the indicated point. We're going to get into more complicated stuff in chapter 3 about when a tangent line exists and doesn't exist. There's 4 big types of things that can mess up our tangent lines that we'll talk about. All right, but I just wanted to kind of show you that as our last example. All right, so I have the homework for you, which is really just the rest of the homework. It's actually day 2 on your assignment sheet, I think. So you should have done this for day 1. Day 2, 9 and 11 are just like the example where you have to find the equation of the tangent line, the slope, the equation of the tangent line, the equation of the normal line. 15 and 17 are kind of like the ones we just did, where you have to see if the slopes match up. And then 23, 25, and 27 are going back into like velocity. Same idea using limits. 31 we'll probably talk about tomorrow. That's a good one. And then 33 gives you some, it's kind of like number 7, only it's more of a story problem, where they give you a year and they give you national defense spending, and they ask you to find average rate of change. And then I let you stop after C, but feel free to go ahead and look at the other ones about getting that equation for a tangent line maybe. But I just gave it to you for average rate of change. The big thing that we're going to talk about for the test tomorrow for these last couple sections is knowing what the directions are asking. If it says find the average rate of change, don't do the limit stuff. If it says find the instantaneous velocity, do the limit stuff. Like, so much of it is understanding what it's asking, because I will not tell you during the test, does this mean do the limit thing, or does this mean do the slope thing? I won't tell you, because I want you to make sure that you know that. So tomorrow I'll give you a printout of like important things I think you should study, and I'll also give you review questions. But then we are going to take the test Wednesday and Thursday, which means that you might want to come in early Wednesday morning or see me Tuesday during the day as you work on it to get questions answered. I do know that the back of the book for our review has both even and odd answers in it, so you'll be able to check them all. But if you don't get them right, then you're going to want to see me before we take the test on Wednesday to do that. That also means homework for chapter 2 is due this week. So if you're behind on homework, you want to make sure that you catch up on that.